Nobody lied to you about the speed of light. That needs to be said first, because what I'm about to show you feels like something was deliberately hidden. It wasn't hidden, it was simplified. And then the simplification got repeated so many times in so many classrooms, in so many television documentaries, through so many confident physics teachers and science writers and pop physics books, that the original version, the messier and stranger and more honest version, got buried underneath it. What I want to do now is dig it back up. The actual claim Einstein made in the 1905 paper is considerably narrower than what you were taught. Here is the precise statement. No object with rest mass can be accelerated to the speed of light from below. That is it. That is the constraint. Nothing travels faster than light. Not the universe has a hard cosmic speed limit. The specific technical claim is about massive objects being pushed through C from below. As you push a massive object toward the speed of light, the energy required to push it incrementally faster increases without bound. It approaches infinity as you approach C. You can never close the gap. The energy cost becomes infinite before you arrive. The wall is real and it is absolute for that specific category of thing, and Einstein was precise about saying so. But look carefully at what that statement does not say. It says nothing about things that were never below C to begin with. It says nothing about space itself expanding. It says nothing about quantum correlations, wave phenomena, or manipulating the geometry of space-time rather than traveling through it. The leap from what relativity actually forbids to the headline slogan, "Nothing travels faster than light," is an extrapolation, a useful one. A defensible one in many contexts, but an extrapolation nonetheless. And extrapolations always have edges. The trouble is that the edge of this particular one has been treated as solid ground for a very long time. Start with the case that has been sitting in plain sight in mainstream cosmology for decades, and that almost nobody has fully absorbed the implications of. The universe is expanding faster than the speed of light right now. Any galaxy more than roughly 14 billion light years from us is currently receding from us at a velocity greater than c, not slightly greater. Some galaxies are moving away from us at 2 or 3 times the speed of light, some at the outermost observable edge at 5 or more. This is not a fringe claim. It is standard cosmological physics present in every graduate level textbook on the subject. The Hubble constant, currently measured somewhere between 67 and 73 kilometers per second per megaparsec, depending on which observational method you trust and which tension in that measurement you're willing to live with, tells you directly how fast space expands per unit of distance. Do the arithmetic at sufficient distance and you get recession velocities well above c. We accept this completely. Nobody considers it a violation. Nobody loses sleep over it. The reason given is that galaxies are not moving through space faster than light. The space itself is expanding. The metric is growing, and the galaxies are locally stationary in their own patch of space-time. This is technically correct, but notice what that distinction is doing. It protects the speed limit claim by defining speed in a very specific way. Motion through local space-time, not rate of change of separation between points. That is a definitional choice, not a discovery about nature. You are allowed to make it, but once you've made it, once you've said that the separation between 2 points can grow faster than c as long as neither point is moving superluminally through its local. Space-time, you have opened a specific door, and Miguel Alcubierre walked through it in 1994. Alcubierre was at the University of Wales when he published a paper in classical and quantum gravity showing that Einstein's field equations, the equations at the core of general relativity, have an exact solution describing a bubble of flat space-time that moves through space by contracting the space-time ahead of it and expanding the space-time behind it. Exactly like the cosmological expansion, just locally engineered at a smaller scale. Inside the bubble, nothing moves relative to local space-time. No time dilation, no relativistic mass increase, no acceleration whatsoever. The occupant inside experiences completely ordinary physics. But the bubble itself moves at whatever velocity you write into the metric, any multiple of c you choose to specify. You put the number in and the equations accept it. General relativity does not forbid this, not in principle. The equations say yes. The objection raised is energy. The original Alcubierre metric required negative energy of roughly 10 to the 64 joules, equivalent to the mass energy of something like an exotic Jupiter mass with negative energy density. Nothing of that type has been confirmed to exist at that scale. Harold White at NASA Johnson Space Center published work around 2012 arguing that modifications to the geometry of the bubble could reduce the energy requirement by many orders of magnitude. His specific numbers have been disputed by other physicists, but the fundamental point, the one that matters for this argument, is that the objection to the Alcubierre drive is not that general relativity forbids it. Relativity permits it explicitly. The objection is an engineering objection. Engineering impossibility and theoretical impossibility are entirely different categories, and we have never confused them in any other domain of physics. In 2000, Lijun Wang at NEC Research Institute in Princeton published a paper in Nature reporting something that caused a controlled kind of panic in the physics community for roughly 2 years before being quietly filed away under things we understand and prefer not to revisit. Wang sent a laser pulse through a cell of cesium gas and measured the group velocity of the pulse at 310 times the speed of light. Not 1.1 times c, not twice c, 310 times c. And the peak of the pulse exited the far side of the chamber before it had fully entered the near side. This was not a measurement error. The result reproduced under careful conditions. The paper was peer-reviewed by physicists who understood exactly what the numbers implied. The editors at Nature debated whether to publish it. They ran it. The response that went up from the physics community within weeks. No information was transmitted faster than light. The Gaussian pulse has a leading edge that carries predictive information about the full shape of the pulse. The cesium medium used this structural information to reconstruct a premature peak on the far side. The pulse was not transmitted. It was reconstructed from prior information already contained in the leading edge. Therefore, no signal, no causality violation, relativity stands. This argument may be correct. There are reasonable technical grounds for it. But watch what it does to the original claim. The original claim was that c is a speed limit, something propagated at 310 c. The response was not to revise the limit. The response was to reclassify the thing that exceeded it. It wasn't carrying information in the technically relevant sense, so it doesn't count. The speed limit now applies not to speed in general, but to causal information transfer. That is a redefinition. The limit has changed its shape. Narrower may in fact be the more honest and precise version. But it is not what most people mean when they say nothing travels faster than light. And the redefinition happened without any announcement that a redefinition had occurred. Günther Nimmt at the University of Cologne spent decades studying quantum tunneling. When a quantum particle encounters a classically forbidden barrier, quantum mechanics permits it to appear on the other side without classically traversing it. The probability amplitude leaks through the barrier and the particle materializes on the far side. What Nimmt documented, entirely consistent with a theoretical prediction Thomas Hartmann had made in 1962, is that tunneling time saturates with barrier thickness. Beyond a certain thickness, increasing the barrier further does not increase the transit time. The effective transmission speed becomes arbitrarily large for sufficiently thick barriers. Nimmt transmitted Mozart's 40th Symphony through an evanescent microwave barrier at a measured 4.7 times the speed of light. He was not being poetic. He argued in print, repeatedly and in technical detail, that he had transmitted information faster than c. The community's response was that a continuous harmonic signal carries no Shannon information in the technically relevant sense because its behavior is entirely predictable from its leading edge. Nimmt disputed exactly this characterization in the literature for years. Two serious physicists with serious training looking at the same experimental data, reaching contradictory conclusions about whether the speed of light was violated. That is not what settled questions look like. When an electromagnetic wave travels through a hollow metallic waveguide, its phase velocity, meaning the speed at which the crests of the wave travel along the axis, always exceeds c. This is a standard result from classical electromagnetism, derived in the 19th century and taught in every undergraduate course on the subject. Every electrical engineer learns it. Almost nobody connects it to the speed of light debate. Phase velocity in a waveguide equals c divided by the sine of the angle the propagating mode makes with the long axis of the guide. That sine is always less than 1 for any bound guided mode. Therefore, phase velocity is always greater than c. Every microwave oven, every radar installation, every waveguide in every piece of electronics manufactured in the past 100 years, superluminal phase velocities, constantly, ubiquitously, in your kitchen right now. And we say, nothing travels faster than light. The answer given, phase velocity doesn't carry energy or information. Group velocity is what matters, and group velocity stays subluminal. Correct. But we have again narrowed the claim without announcing the narrowing. Speed in general has become energy transport. A universal headline claim has become a specific technical constraint on a carefully defined quantity. The pattern keeps repeating. Here is the case almost nobody discusses outside of graduate quantum mechanics, and the one I think should sit with you longest. De Broglie showed in 1924 that every particle has an associated matter wave. Every electron, every proton, every neutron, every atom in your body, the wavelength is Planck's constant divided by momentum. This is not peripheral to quantum mechanics. This is the foundation of it. The Schrödinger equation describes the evolution of exactly this wave. The phase velocity of the de Broglie matter wave, the speed at which its crests travel, is c squared divided by v, where v is the velocity of the particle. Work through that arithmetic. If a particle moves at half the speed of light, the phase velocity of its matter wave is 2c. If it moves at 1% of the speed of light, the phase velocity is 100c. For any massive particle moving at any velocity below c, which is every massive particle that has ever been measured anywhere, the phase velocity of its associated matter wave always exceeds c. Always, without exception, right now. Every electron in your body right now. The wave that quantum mechanics says completely describes its physical state. Phase velocity greater than c. The dismissal, the wave function, is mathematical, not physical. It is a probability amplitude, not a real propagating field. This distinction carries genuine weight in quantum mechanics, and I am not dismissing it casually. But the wave function is the thing doing all the physics. It determines where the particle is detected. It determines how the particle interferes with itself in a double-slit experiment. And calling a superluminal quantity mathematical rather than physical is an argument that requires far more scrutiny than it typically receives. Quantum entanglement is where this stops being about definitional precision and starts being about the foundations of reality itself. Two particles interact and become entangled. Separate them by any distance you choose. Put one particle in your laboratory. Put the other across the planet or across the galaxy. Measure one. The other instantaneously adopts a correlated state. And those correlations are stronger than anything that could have been prearranged when the particles were together. Stronger than anything they could have carried with them when they separated. Stronger than any local, hidden, variable mechanism of any kind could produce. This is what Bell's theorem establishes mathematically, precisely, and without ambiguity. John Bell was working at CERN in 1964 when he published it. He derived an inequality that any locally realistic theory must satisfy. Locally realistic means particle properties are real before measurement, and influences don't exceed c. Quantum mechanics predicts violations of this inequality. The experiments had to follow. Alain Aspect ran the first decisive Bell test in Paris in 1982. Results violated the Bell inequality. Technical loopholes remained, theoretical gaps through which a local, realistic explanation could just barely squeeze. Over the following 3 decades, experimenters around the world worked to close those loopholes one by one. In 2015, Ronald Hansen's group at Delft University ran what became the first genuinely loophole-free Bell test, closing both the detection loophole and the locality loophole simultaneously in a single experiment. They used entangled electron spins in nitrogen vacancy centers in diamonds, with stations placed 1.3 kilometers apart. 9 days of data collection, 245 valid trials. The Bell inequality was violated. The p-value was approximately 0.039. Simultaneously, separate groups at NIST in Boulder and at the University of Vienna ran parallel loophole-free experiments and independently confirmed the violation. Local realism is false. Not tentatively, not pending revision. The universe does not operate according to locally realistic principles. Either there are real influences propagating faster than c, or particles genuinely have no definite properties before measurement, or some form of retrocausality is at work, or something else we haven't yet fully formulated. Bell's theorem leaves those as the remaining options. None of them sit comfortably with the clean picture in which C is a hard boundary nature enforces everywhere and always. The no signaling response is always raised at this point. The correlations are non-local, but you cannot use them to send a message. Individual outcomes on each side are random. You need a classical channel to compare nodes and extract the correlation. Classical channels are capped at C, so no causal signal crosses the light speed barrier. No information, no violation. Follow that logic carefully. There is a real non-local influence connecting entangled particles. We know this because the correlations exceed every bound that local hidden variable theories can produce. And local realism has been experimentally falsified. We are classifying this as not a violation of the speed limit because the influence cannot carry a message. The influence is real. The non-locality is real. We have drawn the speed limit line specifically at message sending capacity, not at speed or at the existence of non-local effects. That is a principled place to draw the line, but it is not the original line. The original claim was about speed. We have, through individually defensible steps spread across decades, converted it into a claim about causal information transfer. Very few people registered the conversion as it happened. Bell himself registered it. He wrote in multiple published papers that the non-local character of quantum mechanics troubled him deeply and pointed at something incomplete in the theory, not a feature to be smoothed over with no signaling arguments. He was the person who proved the theorem that made all the Bell tests possible. His unease deserves serious weight. On tachyons, Gerald Feinberg proposed them in Physical Review in 1967. Hypothetical particles that always travel faster than c. Never observed, no experimental evidence, but not forbidden by special relativity. Relativity forbids accelerating a massive particle through c from below. It says nothing about particles existing entirely above c. Tachyons would have imaginary rest mass, a mathematical feature ensuring they can never slow to c from above, just as massive particles can never accelerate to c from below. The theory is structurally symmetric about the c boundary. The statement, "nothing can travel faster than light," was never derivable from special relativity in the first place. Nothing is an extrapolation from a specific constraint about crossing a threshold. That extrapolation was never labeled as such. What c actually is in the structure of the theory is the deeper question. It isn't just a speed. It is woven into the geometry of space-time itself. The metric, the mathematical object that tells you how to measure intervals in space-time, has c embedded in it as a conversion factor between spatial and temporal dimensions. The light cone, the boundary separating events that can be causally connected from events that cannot, is defined by c. Whether event A can cause event B depends entirely on whether A sits inside the past light cone of B. Change c and you don't change the speed. You change the geometry. You change what it means for things to happen in sequence. You change the structure of time. The speed limit framing persists because it isn't about speed in the ordinary sense. It's about the architecture of causality itself. A genuine causal signal propagating faster than c could, in principle, construct closed causal loops. A causes B, B causes C, C causes A. Cause and effect become indistinguishable. The logical framework underpinning all of physics dissolves. The speed of light as a limit is really a causality preservation rule expressed in units of velocity, which is why the claim attracts so much resistance to revision. But quantum mechanics creates a problem for this picture that quantum field theory only partially resolves. Quantum field theory, the framework combining quantum mechanics with special relativity, is Lorentz invariant at every tested energy scale. Space-like separated measurements commute in the formalism. The causal structure holds. But quantum field theory excludes gravity. General relativity excludes quantum mechanics. At the Planck scale, roughly 10 to the 19th power GeV, 16 orders of magnitude beyond the LHC's maximum reach, quantum gravitational effects become significant. The smooth space-time geometry of general relativity is expected to break down entirely. The sharp light cone structure may not survive into that regime. We have no data from there. We have no instruments capable of probing it. In loop quantum gravity, space is quantized at the Planck scale, and the smooth manifold of general relativity emerges at large scales from a fundamentally discrete structure called a spin network. What causality means in a fundamentally discrete space-time is an active research problem with no settled answer. In string theory, extended objects replace point particles, and a form of non-locality enters at the string length scale. How the causal structure behaves there is not fully resolved either. Both frameworks suggest the light cone of classical relativity is an emergent feature of the low energy regime, not a fundamental feature of the deepest structure. If the light cone is emergent, then the speed limit built into it is also emergent, valid in the regime in which it was discovered. Potentially different in a regime we haven't yet reached. Every fundamental limit in the history of physics eventually turned out to be the edge of an approximation. Absolute simultaneity was a limit until Einstein showed it wasn't. Determinism was a limit until quantum mechanics made it probabilistic. The pattern is consistent across over a century of physics. We are inside that pattern again right now. We cannot yet see the endpoint from where we stand. I want to be precise about what I am not saying. I am not saying information travels faster than light and we simply haven't learned to use it. I am not saying any experiment has conclusively demonstrated a causal superluminal signal. I am not saying special relativity is wrong. The experimental record is consistent with the relativistic causal structure in every tested regime. That is significant and it matters enormously. What I am saying is that the speed of light is a speed limit conflates three distinct claims that almost nobody separates. The first, massive objects cannot be accelerated through c from below. Solid, uncontested, confirmed in particle accelerators millions of times over. The second, no physical influence of any kind propagates faster than c in vacuum. Strongly supported by macroscopic experiments, maintained through careful redefinitions of what counts as a physical influence whenever something apparently exceeds c. The third, the causal structure defined by c is fundamental at every energy scale and in every possible regime. This is an extrapolation into the Planck scale where our two best theories mutually contradict and where we have no experimental access. All three are taught as one statement. They are not one statement. The first is rock solid. The second is strong but carefully managed. The third is an assumption. Bell tests falsified local realism. Alcubierre showed general relativity permits superluminal bubble motion as an exact solution. Feinberg showed tachyons aren't forbidden by the theory. Wang measured 310 C. Nimtz measured 4.7 C through a tunnel barrier. De Broglie phase velocities exceed c for every massive particle in the universe at all times. Waveguide phase velocities exceed C in every piece of microwave hardware ever built. Each individual case gets explained away. The accumulated weight of all those explanations starts at some point to feel less like evidence that C cannot be exceeded and more like evidence of A. Framework specifically engineered to prevent any observation from ever threatening it. Maybe the framework is exactly right. Maybe the no signaling principle is absolute and will survive whatever unified theory eventually arrives. Maybe C is as fundamental as anything in physics. But what physics cannot honestly say right now is whether C is a fundamental feature of the deepest structure of reality or the most reliable approximation ever discovered. Those two possibilities are not the same thing. The distance between them is where the next century of physics has to go. And we don't know yet which side we're standing on.